because it's going to release by the pressure valve anyway. And then this is wired to the pressure switch. Yeah, and the PCM will handle turning the compressor on and off based on the state of the pressure switch and the enable state of the robot. And this is air tank. The air tank is designed to withstand up to 125 psi, and the temperature is from 35 to 100 degrees Fahrenheit. So this is why the pressure switches. The release valve is important, because if it exceeds 125 psi, for example, right, then the pressurized air in the air tanks will be too much for the air tank to withhold. So it might like explode or like disconnect the tubing on the side. So that's why the the relief valve, it's important to keep the psi in the system to 120. And this should also be mounted to a secure place on your robot, because you don't want the air tank to be hit by any robots or anything else. Because air tank stores all your PSI in your system, and if you don't have an onboard compressor, then this is the only thing you have to store it, and there's no way to like pump more pressurized air into your system during the competition. And this is a pneumatic regulator. It is a relieving factor regulator. So what it means is it will limit the downstream system pressure and can relieve excess pressure if something in the downstream system causes pressure to increase. So for example, if you have a pneumatic cylinder that you only want to output like 30 psi, for example, so on one side of the tubing it will have 60 psi, but the other side, since it's going through the regulator, it's only going to have 30 psi, because the other 30 psi it's going to be released by this regulator. And this regulator can only output 60 psi, and the pressure is adjustable and may be reduced for use on your robot based on your needs. Oh, and then one important note is that during the competition, the working PSI, the working pressure, can only be 60 PSI or below. It cannot exceed 60 PSI. And these are the pneumatic gauges. These gauges should be installed in the system to show stored and working pressure. This means you are usually required to have 2 or more pneumatic gauges. So stored pressure are basically the pressure stored in your air tanks. So normally it will be around 120 psi, but the working pressure, it's what you use those pressures for, and normally it can only be 60 psi or below. And I see note that the working pressure gauge may not exceed 60 psi. That's why one of your gauges should always show 120 psi, and the other one should always show 60 or below, if you have multiple, gauges. And these are like what we commonly use in pneumatics. We have fittings which connects one component to another, and these also prevents air leaking out from the system. We have tubings transferring the pressurized air, and then the cylinders or any other pneumatic components that you want to use on your robot. Setup for the air compressor. So as you can see, this is an air compressor, and here this is a pressure release valve, and then you can turn these knobs based on what psi you want to keep it at maximum. And here it's like a common setup for how you release the air. So if you want to release the air in your system altogether, you will turn this little switch over there, and this gauge shows the stored pressure, so it should always show 120 psi. And this one is a pressure switch, so it's connected to the PCM, and then it basically turns the compressor on and off automatically. And that's basically it for pneumatics. Any questions, or Joe or Hannah, if you want to elaborate on anything? Pneumatics is pretty easy. You barely need to like crimp any stuff. You only need to cut tubings and stuff. and you just have to like know which components for what use, and just connect the tubing, make sure the PSI is right, and yeah.
Yeah, pneumatics is not too complicated like Albert. It's pretty easy. I think there's some numerical calculations involved, right, Albert?
It's
Yeah.
mostly just like calculating, like depending on what manipulators you have, it's just like you need a certain amount of PSI and you kind of just divide the total number by like the amount the tank can carry. So like you said 120 PSI, right? For each tank? Or
Yeah, each tank can store 120 PSI.
yeah, so say like each manipulator, like altogether they require a total of this amount of PSI, you just divide that by like 120 and then that's the number of air tanks you use on your robot.
Yeah. Yeah, it's not too complicated, and yeah, we just have to, like Hannah said, we have to adjust based off what our manipulators are. So if our manipulators require more pneumatics, we like increase the number of tanks and things like that. But yeah, stuff like that. Yeah, pretty good. Any questions, anyone? All right then. So if we don't have any questions, do we just?
I think we can just end it here.
All right.
You can also, yeah.
Yeah, sorry, Hannah, you were gonna say something?
No, I was just gonna say like you can stop the recording now because she's like.
Okay, and for the next meeting, we are probably gonna talk about like something about like the CAN bus and like other like small topics in electrical. And then the meeting after that, since electrical is mostly hands-on, we might let you we might not have like an electrical workshop, but we might let you go like to software or mechanical workshop until like we're actually back in school, so we can like actually do the crimping and electrical trainings and stuff.
I'm back.
Yes, honey, we
Hello.
finished.
We finished.
Oh man. Oh, I can't learn anything.
Sorry.
Hey guy, if we finished, then if you guys want to join another group, then join another group, okay?
Sounds good.
Then see you guys on Thursday.
All right.
Thank you. Good job.
Bye.
Thanks for coming, guys. See you later.
Bye, guys.
See you.